Okay, and morning. So as usual lah, 8 a.m. plus right, time for others to join us. So yesterday we have complete some of the part of chapter 1, but I will continue with on the previous slides more. This is the one. Okay. Okay. Today we'll continue with first chapters. Hopefully, others will join us later. Is it okay? You can see the slide? Enough? If not, I change to the screen. I try to access it from here. Yes. Yes. Yesterday we complete until this one, right? School deployment we have got, but is it the one which highlight in your textbook? So today we continue with defense in depth and attack surface. What mean by defense in depth here? Defense in depth meaning is it defense your assets, asset and whatsoever in very details one. Can say that it's more on overall protection, right? In depth, everything you need to protect from the risk of threats. Okay, then you need to ensure the attack surface will be minimized. So reduce the attack surface, lower the number of potential entry points. This is the concept. When you reduce attack surface, meaning that the numbers of potential points will be reduced as well. Lower it, so the risk will be lower. So from here, you can see that's 3. So if you have very deep protection, maybe layering the protection, many layers, okay, from physical, logical, network application, and so on. So you will get lowering your risk. If, for example, your defense are shallow, meaning there are some defense, but there are another layer you did not have proper defense, So you will be go to the medium security risk if your attack surface small. But if your attack surface large, it will be higher. So meaning you need to ensure you understand your attack surface and then how you implement your defense depth. So this is the best one, right? If you put the heat map here, for example, this is the best one. Meaning you need a deep defense in depth, and then you maintain the small attack surface. But very difficult because nowadays most of company, most of organization having many application, right? A lot of application in MU as well, right? So how many application for MMU you use? For you all for students? Two. Device, what else? Click. Anything else? Later style they have their own. Then synergy they have their own, right? So they have many. If you have many type of application, so that will be until here lah, will be have large number of attack surface. However, company they have their own protection. For example, in banking system, right? They know they are required to engage and to reach all the client, right? How many client? Million of client. So if they say they want to expand their business, not only the local environment. For example, we have here local bank, right? How many local user? For example, maybe 20 million, because maybe children don't have, right? 20 million. But we want to expand their business into international level. I think CIMB, Maybank, they have Asia region, right? So the attack surface will be larger, right? They cannot afford to maintain a small activity. But what they need to do, they need to reduce this high security, high security risk into medium security risk. They cannot, maybe they cannot do like this, but they need to reduce into medium security risk by implementing very good or very deep defensive depth, right? Deep defensive mechanism. However, it still can reduce the attack surface by minimizing exposure of the application. For example, for end user, no issue. They can go for public cloud. Then they open to international access. But for their core business, for example, their core server, their core banking system, they still put in their own premise and then a very secure environment to only specific type of user can access. So that's how they manage it. So for Malaysia, we have Bank Negara, RMIT, Risk Management in IT, where they have this. Try to reduce the attack surface and then implement that. So that's why the mobile banking nowadays require many things, right? So when you want to transfer your the money, you need to authenticate from mobile apps. Last time, they are using TAC, right? TAC meaning TAC code, and then they got many type of code using SMS. But we know it's not secure because the SMS can be hijacked and so on. So that they implement multiple authentication. So this is how they work. While increasing defense index, provide multiple protective barriers, right? So defense index here normally they will have multi-layer protection from user side, IAM, identity and access management, and then they have also network layer security, firewall and so on, application layer. So here, this is the conclusion. The lowest risk is achieved when both the attack surface is minimized and multiple layers of security control are implemented. Right? Oops. Okay, this one easy to understand. Okay, I can read from here. Have many layer. Okay, reduce your this many layer of protection. Okay, this one. In this book, they divided or they classified attack surface into three types of attack surface. But there are a lot more, right? This is the common attack surface type that monitored by the attack surface management tools. First, we have a network attack surface, network layer, referred to vulnerability over an enterprise network, a wide area network of the net. So from here, what we mean by enterprise network? Is it your home network? Considered enterprise? No, right? So enterprise meaning the organization level. For example, MAB considered enterprise or not? The TM, right? So there are numbers of users where attack surface will be here. Okay. So from here, the network, you have network protocol vulnerabilities. For example, using email protocols, right? There are some vulnerabilities. You are using telnet, you are using a type of file transfer, FTP. So this is the vulnerability. Can cause denial of service attack, disruption of communication between minimums. This is network surface. So network surface is common because when you using IT system most of the time, now we are interconnected. So you need to ensure attack surface in the network layer also minimized. We cannot close 100%, right? Because if you close 100%, maybe your application cannot be accessed from internet. Locally, maybe can, but we need to reduce it to minimize the this. So that's why some company they are using VPN only for specific application. But for end user, their client normally they didn't use VPN because it's troublesome, right? But if they are using for internal use, then they will use VPN. And then software attack. So meaning this is the application layer, refer to vulnerability in the application, utilities, your Microsoft Word, PDF, they have also their own vulnerability for operating system code itself. Anyone have experience attacked by ransomware? Anyone? Don't have. Okay, about the ransomware, I think last 5 years, I think around 2021, 2022, my previous university. So we have that case where our lab been attacked. Because we are open at that time, the lab used by FYP student, network security student, and then suddenly during my lab session, student asked me, so I cannot open packet tracer. already encrypted, everything encrypted. I checked, there are 5 out of 20 PCs have been affected. So shut down first, and then discuss with the lab manager. I think just remove, just we call clean up everything first, right? Because if we still connected to the lab, connected to others, they will be affected. Luckily, there are no FYP student file there. But for enterprise level, if they affected by ransomware, it's a bit difficult, especially when there are some fault or some database content don't have the backup. So we need to ensure the file can be recovered again. And the third one about the human attack surface, and this refer to vulnerability created by personal outsiders such as social engineering, human errors, and trusted insider. Actually, this is another part where very difficult to deal with because we don't know human. If software network can monitor, we have SOC, NOC, web application scanner, but this one human surface attack, how we can scan? I want to scan you. How I can scan you? Even difficult. Don't be a lot of difficulties because last time I do a lot of awareness campaign, simulation, talk, cyber day, whatsoever, but still our people are vulnerable, right? They are doing whatever they want. So we can have a process, technology, but the people itself must be uh, carried or properly managed. Not only our insider, outsider, third party. So we have to develop very good policy for process part so that we can monitor our vendors, so on. For example, last time I appointed external pen tester, 2%. So we only give them very limited access from their own laptop. So the username, password only limited to specific time frame. And then we ask them to do, for example, the pen test only after midnight. So they should be okay. So meaning they can do their job from 12 to 6 only. So the access to the VPN only for 12 to 6, depending on your requirement. But if they not willing to do that, we need to find another way. So the human error. And then for human error also, normally they also type with software. For example, there are managing specific play, managing specific roles in the system, financial system. Need to ensure they only have very limited access to these particular things. And then you need to ensure the software also have their own logs. This is a requirement nowadays, especially for the financial related system, SAP. Right? So they need to have the log, maintain the log, for example, for 1 month. But there are challenging part where the storage of the log. You need to store the log for 1 month. How? Because if anything happens, for example, the fraud cases, and then maybe the misuse of the roles, how they deal with the transfer, need to check and make it ready for forensics. Because nowadays, there are many applications in the market, but on the shelf, normally they don't have this particular features. So when we want to do forensic investigation, it's not ready. So not work, right? And then this is example of use case attack 3, right? For internet banking authentication. This is from textbook. You can see how the bank account can be compromised, right? Through these three. Three meaning they have the first layer, second layer, and third layer, right? The three itself. For bank account compromise can be caused by user credential compromise, or can caused by injection of command. For those that enroll ethical hacking course last time, this is the common one for them. Use injection attack, right? And then user credential caching. They still have possibility, but it's quite difficult. And then this one, security policy violation, meaning the bank system itself, use of non-authenticated session by attacker. And this is the first three, first layer. So for example, we go through the first part. If they are using user credential compromise, how they obtain this kind of credential. There are multiple ways to do it, right? For example, they use user surveillance, try to see, for example, some sort of CCTVs and so on. Last week, I went to one of the banks because they need to create the temporary ID first before I can create the mobile banking. Then after that, after I create the mobile banking account, they need to activate the mobile secure one more time. So I need to log in inside the bank ATM area. So I see, is it any CCTV or not? Because this is the surveillance one. We don't know, right? We need to ensure no one will see what we did. So they can also use theft of token and handwritten notes, because we know there are a lot of applications nowadays. We can't afford to remember everything. We will write somewhere, and we can we store in the phone. This can be done as well. Malicious software installation, this can be done as well. Last time during my cyber day, I invite speaker from one of the NGOs I did. Okay, simulate how malicious software can be installed to your APK, your APK. Similarly, in our collecting we did before. Then smart card analyzer, smart card reader, manipulator, this is more on the bank card, right? Brute force attacks with pin calculator is possible, but be difficult to do it. Sniffing and other user communication. So, can you see here? One another common one using malicious software. So when your phone, for example, your laptop compromised by the malware, so they can exploit the vulnerability inside the phone and take over your phone or your machine, or they can send whatever file they require. So they can put hidden code, the worms, can use email with malicious code. So this can be happen. Malicious software installation. So we can use Metasploitable or Metasploit package to do this. Okay, for your information, most of the time when we detect user authentication or user credential compromise or credential theft, so that time we have our attack surface management and also SOC report. We found there are a lot of user credentials have been compromised, especially related to our organization, using email and then the password. Then there are some end user. That's for company using email. Our end user is our client. The client, we have the system for the client, but we can detect that client compromise or their authentication or their credential have been stolen by how they access our system. And then most of the time, the originality of the authentication theft or credential theft really from the device. Okay? The laptop compromised, and then they take over the credential, and then they can access. Okay? Normally our attack surface management tool, they will list everything. That's mean username, password, credential, and password. Sometimes they just masking, so you can find it for your own user data. Okay, for our user last time, we found there are a lot. And then at the same time, SOC also can detect multiple attempt, failure attempt, because every month we have our report. So we found that there are certain users having brute force attack from outside, from Hong Kong, in China, sometimes until 30K times only that particular user. So we ask the user to change the password. Sometimes we just eliminate the user if the user not active anymore. So this is how they did. Sometimes we don't know. Maybe they are bots, right? Okay, for the user communication, there are another techniques here. They use social engineering, web page obfuscation. What I mean by this? You can find. So they create the fake web page and redirect communication to fraudulent site. This happens especially using phishing and also nowadays we have WhatsApp, right? WhatsApp scammer. So they give you the link. Okay, this is the file that you need to read or to write or to open, for example. Actually, APK file, which redirect you or install the malware. Right. Other than that, I think this one understand easy lah. Easily, normal user. Okay. For this one, anything that you want me to explain more? Or you can find by yourself. Easy, right? Most of it common. Okay, this is a sample of bank attack surface, but there are a lot more use cases. But this is user lah, not user part. Okay, this is attacker part. But the insider part, meaning what? The insider attack, insider from the bank. Maybe they have the access to the user account, but they manipulate. So this is very difficult to deal with. This one for chapter 1 lah, right? Okay. Any question before we move to chapter 2? Anyone have facing this type of attack or this type of compromise? Or maybe they know you still try. If they say your parents, your parents have a lot of money, so they try to persuade. Okay, no question, maybe we can move to second part. Fundamental, very fundamental, right? But try to give you some exposure. Okay, the second chapter here about cryptography. So before I forgot, next week, Monday, we have class 10 to 12, right? So 10 to 11, you will continue our lecture. And then 11 to 12, they are visit from, I think, Portsmouth University. So one of their academician will give talks about cloud security. So our class will join them. Please make sure you come. There are some insight for those that want to ask about the latest technology or latest security issues in the cloud. So we can ask. So really part of our syllabus as well. If you see, it's one different. Maybe I can check here. Can you access to our syllabus? Our faculty manager can access this syllabus. many different access. For student. So this is what I shared yesterday, right? For the committee and so on. So I got email from one of you about how the marks, the minimum marks, right? Minimum marks meaning you need to score at least 40% for both component. The both component have the assessment, cost and final assessment. Meaning that for this part, so 70%, that means 40% of the 70 must be passed for coursework, and then another 40% of 30. Meaning how many? 40% of 30? 12. 12. Minimum 12. Make sure you can score minimum 12 for final assessment. But don't target 12 lah. Target like 20 and above, 25, right? But this one, 70, how much? 40% of 70. You know, for continuous assessment, no issue normally, right? Then score especially for that exercise. Quiz, right? This is the challenging part, final assessment. Okay. Okay, this one will be announced later. Our last week, so I will booking the venue for you. Because we need additional invigilator as well. Okay. Okay. You later for this course. For assignment, I'm still waiting for moderator. So at this time, maybe you can try to form a group first for papers maximum. What I want to discuss about the guided learning here. You see, from here on 55th, there are some chapters where we don't have lecture. This is lecture, it's practical, but practical and building up. Okay. So meaning for lecture, we only have half of face-to-face. 2, 10 hours, 14 hours. Meaning another 14 hours are guided learning. So we can make it non-face-to-face, maybe online or maybe activities. Okay. But we need to cover everything.
Topic holiday, so we are having the guided learning.
This one not necessarily for community because this one will be stated in course structure, but we can arrange that. The work holiday, so we can try to make it flexible.
How to do our people,
Right? But we want to talk about maybe if public holiday, we try to make it as okay. So this one done. So we don't have any questions about the control risk assessment because later we will go in details about but each of these will be come with the risk assessment trends. For cybersecurity students, they already go through medicine here. Network security, they got one course specifically for network security. Like also cloud and database security. Yeah. Particularly, we have one course. For management, it should be application. Alright, so now we are moving to cryptography essentials. We got two chapters, right? Two chapters for cryptography. T, essentials. And then you can see the lecture also 8 hours. Okay? We will continue again the cryptography essential next week. And another part for public cryptography, another 4 hours. You see, but the practical 6 hours only for cryptography. But this one is not practical. Nobody data will reach. Particularly because why? This will be interrelated with the security model. Now we are moving back to chapter. So you can see your quite clear. This camera, right? Technology, we use it. Okay? We have technology, we need to utilize it. All right. Now we're moving back to our lecture. Don't worry, we have ample time to complete it because we have 4 hours for this chapter only. So today we just I tried to simplify it. So this is your reference book. If you have access to it, either physically or ebook, you can try to find it. So this is the father of textbook, William Stalling. They have this person actually very otai lah, we call it. Right? During my study, also he already have books, operating system, programming, now all the security as well, from network security, cryptography. So this is the bundle of textbook. Okay, for this chapter, this is learning outcome. After you complete this chapter, you are able you should be able to explain the key terminologies related to cryptography. And then I try to give you some example where this cryptography algorithm will be used in the IT environment. And then to identify the classical cipher, okay, and their behavior. Why? Because there are many classical cipher introduced last time, but they have been replaced because of their failure to protect the data information. And then to discuss both cipher and modern design, cryptography, to discuss AES and mode of operation. Because there are a lot more algorithms, but we focus directly to AES because AES still what we call the KTH of the block cipher. It is still used by the modern cryptography, although there are in this AES introduced last 3 decades. I think 1997. This AES have been selected by the committee of cryptography to replace triple dash or dash for replicate cryptography. And then to discuss hash function and message authentication. What is symmetric? Symmetric encryption or conventional encryption, we call it, or single key encryption, was the only type of encryption in use prior to introduction public key encryption of late 1970. Meaning that before we have public key cryptography, public key encryption. This is the thing we're using symmetric encryption. The difference between public key and symmetric, public key have two keys, public and private. Symmetric, you are using the same key. And then there are two requirements for symmetric key in cryptography. Must be strong. This algorithm, encryption algorithm must be strong enough to face any analysis and also cryptographic attack. Okay. The sender and receiver must have obtained copies of the script key in a secure fashion and must be kept or keep the key secure. Because why? Both sender and receiver will use the same key. So we need to ensure the key distribution are very secure. This is the overview of symmetric. So normally these two general approach by attacking the symmetric key, crypt analysis, crypto analysis, crypt analysis, and also brute force attack. So normally crypt analysis will use some sort like mathematical models, try to crack the algorithm and password of the key. Brute force attack normally they only try to get the correct key. Okay, this activity. Identify how the following approach attack a symmetric encryption scheme. So my left cryptography, crypt analysis, and my right brute force attack. Try. You have your phone, right? Your tab. Try to find in 10 minutes how this following approach can attack symmetric encryption. Because later you know when you know how they track, how they attack, then you know how to protect. This one later lah. Just all of you decide my right brute force attack. Try to find how brute force attack will be used to attack the symmetric encryption scheme, and decide to you will become crypt analysis. Okay, in 10 minutes, maybe time to find a way how these two types of attack will be carried out. Right? And this one no issue. And afraid later row 1, row 2 will change the row. Okay, yes, this part of it. Two approaches. Crypt analysis and brute force attack. So you can use any tools, any AI assistant. The security student will have one course specific for people to be right. Okay, maybe you can try to put your answer here. You can list, let's put one. You can list out. force is horizontal to the direction. Nowadays, when there are possibility of further cryptography, right? Further computing, and then now they come up with quantum cryptography. Because why is that? Because when they have quantum computing, they are very fast, so they can maybe see or the computer are very powerful, so they can try to brute force the password or the key in more manageable time. So that's why they come up with post quantum cryptography. Maybe after this AES doesn't work anymore because it can be cracked very fast. Currently, maybe if they're using brute force, it took about 10 years, 100 years to be cracked, right? But after the quantum computing era later, maybe it will be that time. But I'm not sure when the quantum computing will be available in the market. Research there almost 20 years back. But in Malaysia, we still don't have high performance computing. Right? Not we say about quantum, but high performance computing or HPC. But I know we only have one. First mission supercomputer. In 2019, this supercomputer ranked 88 fastest in the world. After that, no more supercomputer. So you know who it is? This guy? This is the founder of this Adam. Adam is his son name. Whisper company. Whisper, you find this is the founder. Founder from Sarawak. This Sarawak kid. This supercomputer made data processing in 2019. But now, they are more defined to be very short. Business will be required this. Nowadays with AI, this supercomputer are on demand. Maybe you can read your answer now. Propose by the implemented test every possible situation. Then, and but it's still require sheet sources by CPU memory. But also force. One more, it's not just only. And when still working for quick analysis, I want to know more. But there are another point other than this mathematical This is right. You are right. Critical, statistical, structural. So there are complete analysis itself that we need. For your question, for each of algorithm that want to be introduced and to be used worldwide, we need to go through the test. Okay, and I expect they have their own test for cryptographic evaluation and multiple type of test. So once we can pass the test, it will be widely acceptable. For nowadays, AES may be common algorithm used by industry, but there are some instances where AES is not suitable to be used. For example, now I have my research in IoT, like IoT security. In order to authenticate my IoT device, I can use AES because AES requires powerful resources, meaning machine grade, right? Laptop, servers. But if you have, for example, very lightweight, yes, this is the lightweight IoT devices. I can afford to run my AES inside. It will be very big penalty for my devices, especially when you want to deploy the devices in mass production, right? We need to have very lightweight efficient. ES doesn't work, so you need to find lightweight cryptography. Anyone else want to contribute about the analysis? Well, good, ready? Okay. Now later maybe you can try to give your opinion on it. Okay. So we can continue with the part here. And this is about the key terminologies for the students. I'm sorry, because we will try to make it simplified because you already go through all the cryptography part. So no more for it, right? So who is your who was your lecturer last time for cryptography? Dr. Vijay. Cybersecurity student? Tika. Who your lecturer last time? Oh, Dr. Chan Royko, correct? Okay. So she will know more about cryptography in other classes, right? I try to simplify first so that IT student so can benefit from it. I need to share 2 times. Okay. So when it comes to the symmetric cryptography, we need to know the terms, the terminologies itself. So first of all, about the plain text. Okay, what mean by plain text? Plain text means the original message, whatever you send, for example, your email, right? Text, password. This is plain text in the readable format of your message or your file. And then you have this one, encryption algorithm. For example, DAS or AES, triple DAS. Then you have secret key shared by sender and recipient. This is secret key where we are use. But for our EB1, EB1, not EB1, EB5, right? Wi-Fi. They are using password, right? Sometimes they call it key or the pass key. But everyone knows, right? It's not secret. Not secret. Right? Everyone knows. It's not secret. But in communication between you, your device, and the access point, they have another cryptography. You can find later. The cryptography algorithm used by this. Maybe later I will ask you to find it. Okay, this is called secret key shared by sender and recipient, meaning both parties, sender and recipient, know the key. If you don't know, you said the recipient can open up, right? Then transmitted ciphertext, meaning here, after the plain text go through this encryption algorithm with the secret key, there will become transmitted ciphertext, meaning the ciphertext here. Ciphertext is the unreadable format, meaning the file or the text will be looks like German language, another language, alien language, right? So it will be transferred into ciphertext. Ciphertext normally unreadable or ununderstandable. You can read, but you can understand it, right? So the equation become y equal to e kx, meaning this x a plain text. Plain text have been encrypt. This one encrypt, e encrypt, k with key, and the plain text have been encrypt in using the encryption algorithm. Become y. Y meaning ciphertext, the unreadable and ununderstandable format. Next, when come to the machine or recipient machine, he or she will decrypt it using the same key, K, and the same algorithm, the reverse algorithm, to decrypt using reverse encryption algorithm. Right? If you're using AES, must be using DES as well. If you encrypt using AES, you try to decrypt using DES, bye-bye. No? No plain text. Maybe you will see different text. Okay? So using the same key to decrypt. And then once you decrypt, they become X again, the plain text. So encrypt can decrypt K and Y. So using Y itself to become X again. So the equation a bit similar like your mathematical model, right? So this is the concept. So you need to use the same key and the same algorithm for symmetric key. So there are, if you see the algorithm itself, there are some round, they call it round of fiction. Last time during my study, I learned cryptography. My lecturer asked me, please prove this plain text into this another ciphertext and plain text in manual paper. So AES, they have 16 rounds of encryption. So each round you need to do all mathematical model to translate from binary to the plain text to binary. So we require 30 pages only for I miss you plain text to decrypt and decrypt again, right? Decrypt and decrypt again. So that's the process. Manually take time, but if using your machine, the program will be very fast. But you need to know the process. Maybe later I will show you the example of the algorithm, because each algorithm they have multiple approach. Okay. Okay, this is the plain text encryption algorithm, security cybertext encryption algorithm. So you see here, encryption and decryption actually the same algorithm but in reverse. So you encrypt to become cybertext, and then you decrypt again to become plain text again. So they have, for example, AES 16 round, the key, then the reverse back another 16 round. With the powerful machine, they didn't take much time. Okay, from this terminology, any question? Easy, right? You understand this one. The text, the original, ciphertext, the encrypted text. The key, why we call it key? Because from the key they can encrypt and decrypt. Without key, we cannot decrypt. So that's why this symmetric key they're using the same key. The issue of symmetric key algorithm or encryption is actually how to ensure sender and receiver have the same key in secure manner. Because if they say the receiver are outside, maybe the receiver in another country, US, how you can ensure the key are securely transferred or informed to them? Is it using different platforms? Right. Okay, this is the concept of classical cipher, and then why they fail. Okay. In classical cipher, they're using this technique. Using replacement. For example, letter in the plain text is replaced by fixed corresponding letter from substitution alphabet. And this substitution approach or technique. Example, this is shaped by tree that also known as a Caesar style substitution, where if the key is 3, meaning they shift into 3 from H to K. Example, H here, 1, 2, 3 become K, right? So if your message is HI, become KL. That's how they shift. This is the substitution, very simple mechanism, but easy to replace. Hello substitute each letter. For example, from hello become KHO1, ho, right? This is the and then when you decrypt again, you need to reverse back 3 letter before, right? This one 3 letter after, decrypt 3 letter before. This is example of very simple encryption. Last time maybe before the computer have been produced. So become hello again. So easy, right? From this substitution method. But for AES, there are combination of this and another XBOR, and others. Because they just using this substitution, very simple and very easy to guess. Secure. Why they are failed? Attacker can use frequency analysis to break it. So they are using only mono-automatic substitution cipher. We know already, only 36, right? In any language, certain letters appear more frequently than others. For example, English, this is very common. ETA, OIN, very common. But QXZ are rare. So, and they can compare frequency of the letter in a sentence with non-language method. So, next, they will use another concept or technique using transposition cipher. Okay. One weaknesses navigate modern cryptography. Because of this one, they navigate for modern cryptography. There are some schemes, they call it escape game. Escape room. Maybe later we can try to play it. Escape room meaning give you some issue or some problem you need to solve. If you don't solve, you can go out. You need to escape yourself maybe there are some part of this cipher, classical cipher to be resolved. Okay. Another part here, transposition, right? Other than some substitution, we can use also transposition. Another method of classical cipher, but still fail because easy to guess, easy to break, right? So where the position of the letter are arranged, but the letter themselves remain unchanged. How we do this? When substitution, we are just change letter A to D, right? A, B, C, D, 3. When the key is 3, meaning they change to next 3 letter. But for transposition, you keep letter the same, but shuffle their order. How do you do that? Example. Syntax in lower, come like this, in lower, key number 3 column, the return message in row, 3 column, hello world. Meaning, they will be like this. They're using the column. Column 1, HLOD, column 2, OER, and then column 3, LW. So, the transposition ciphertext will become HLOD, EOR, LWN. So, this is the transposition. So they are using the column base, this position of the plaintext to ciphertext. If they say like this, if you know the number, you can guess very easily, right? If you don't know, also you can try and error. Why we fail? Preservation of statistical structure. Laser frequency remain visible. Then number frequency analysis attack as well. So high octane letter reveal the epic. Same like this one. In English, they found there are many letters frequently used, but in bahasa Melayu, what are the common letters? Okay, guess. Bahasa Melayu normally we are using A, right? A, I, so on. So there's also part of the tree analysis techniques using the statistical structure. And then another insufficient key complexity. Key space is too small because if you are using very large number of columns, right? But the data are very short. It's not worth as well. So what number is good for us? And then lack of adequate confusion and diffusion. So in order to get very good cryptography candidate, we must have high confusion level and high diffusion level. Right? What I mean by this? Relationship between plaintext, key, and ciphertext is too direct, easy to guess, not confusing, don't have the high confusion level. And then patterns are not sufficient or secure. It can be guessed, right? What I mean by confusion? Obscure connection between key and ciphertext. Very make it difficult to guess the relationship. Diffusion is dissipate statistical structure of the plaintext. So you need to ensure if you want to use good cryptography algorithm, is two component or two concepts must be highly available. And then deterministic and predictable behavior. Some pattern away following the same ciphertext. Okay, repeated patterns are easily detected as well. So because of frequent analysis can be done. Another part here, because of the failure of the classical cipher, is a motivation for modern cryptography. So AES actually considered as modern cryptography, but for post-quantum later maybe different lah. So later we have another class for quantum cryptography, post-quantum cryptography. But for this one, still here, AES still here, they call it modern cryptography. So this happened, AES, RSA, and others, actually to eliminate statistical things. So if they have the statistical information, it can be protected. Should cybertext should appear random, meaning cannot be guessed. The confusion is there, no visible frequency pattern. Because nowadays with AI, if they say we have a combination of quantum computing, combination of AI, is statistical is very easy to guess, right? Then the pattern of the cybertext and plaintext can be easily guessed. So you use large key space. Example, advanced encryption standard make brute force attack computationally infeasible. For example, nowadays, last time AES only have, for example, 128 bit key. Now they can support until 256, 512. Meaning that if we have very large key, very long key, the brute force attack will be difficult because they need to combine the plain text and the key to be compute and guessing, right? The force attack. And then apply multiple round of processing, combination of substitution and computation and repeated transformation, increase screening. That's why I say AES they have 60 rounds of processing. So need to achieve contribution and diffusion in ID consideration, right? This is called the core principle. So implemented through complex mathematical operation. So that's why I say during the candidates AES, candidates of AES in ISP, there are many algorithms come to the competition, but we select AES because of the confusion here, the confusion and also the diffusion. Okay, so AES around then you there are some tools you can try online tools. Okay, have you seen this figure before? This is the AES encryption round. Actually, for decryption, they will be reverse back. Okay. They start with this state, right? So they have 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 15, 16 round, right? To be completed. Right? So each of it must be put through. So that's why I said before last time, I do it manually, one by one. Transform, for example, hello world into binary. To transform into binary, so take time, right? Then try to use the side by the state and so on. Yeah, this is the complexity of AES. So it's from by cell. So the complexity is there, the confusion is there, but So they have multiple states, but state again, and then they should be using shift rows. The row can be shifted in another state, mixed column, another state, and then the round key. Each key they have a round key. If you have time, maybe you can try Francis. If I teach to script the business, I will have to do it one by one, not manually, but try to find the tools, see how step by step. But if you fail, incorrectly identify one round and later another round of it. Okay. Now I just want you to see how your Wi-Fi. Can you see your Wi-Fi? Can you connect to EV5? EV5, right? Can you see what type of encryption algorithm used by your EV5? One cable lah. I don't have here. The one to connect. So they already have cable here. Okay. Connected. So what type of what algorithm they use? Can you tell me? For EV5. WPA 3 personnel. How you find it? How you find the algorithm here? It's one. You see here. So how you can identify the type of algorithm used normally? We are using what type of Wi-Fi? Wi-Fi 5, Wi-Fi 6. Now the latest Wi-Fi, Wi-Fi 5, 7, 7. Right. So you find there are another different type of algorithm. One, Wi-Fi 5 is still using ESCCMP with 128 BT. Still can be enhanced. For WPA 3, using SAE, equally simultaneous authentication. Well, this one use the Helmet ECC exchange. Support. I thought the exchange will be our access point, Wi-Fi 6, Wi-Fi 7. Okay. Wi-Fi 7, A, AX, or Wi-Fi 7? AX, Wi-Fi 6, right? Wi-Fi 6. For Wi-Fi 7, they name it as what? Yeah, anyone know? Later, your boss asks, we want to upgrade for the latest version. So you need to upgrade not only your IP, you need to upgrade your switch, your core router, right? Your devices and device. If they say your core router, your AP can give you until 100 to 1.2 BT. Okay, BE. Is it? Wi-Fi 7. Okay, we can find here Wi-Fi 7. Using another GCMP, right? You can use until 6 gigahertz. And then for 5G, they got different. If you want to upgrade, for example, you need to ensure that maximum performance must be similar, right? Because some of user they said, okay, I already subscribed with Wi-Fi 6, which, for example, in Unify Unify phone, right? They subscribe 1 gigahertz. But they said my laptop only found only 500 megahertz. Maybe right. But why? Because the network type of the laptop does not support. You need to make sure all the devices are support each other so that you can have maximum capability of maximum bandwidth. So this things, okay. Okay, now what else we want to cover? Yeah. Okay. And then we move to the block cipher. Slide 5, right? Oh, block cipher. This is the model of the block itself. The concept of block cipher actually they process the plain text in the fixed size block. That's why they call it block on block. For example, if you have the text, you have very long text, one document, work document, then it doesn't send everything in one document. They will include, for example, 64 byte, for example, fixed block size, maybe one page per page, one page each, depending on the block size that you set, right? So each of the block size of ciphertext will be the plaintext will be transformed to the block ciphertext equal each plaintext. And then if they say that DS support until 64 block, AS support until 128 block, but the key size can be until 256, 128, 192 or 256. And then I'll process lighter plaintext upon as a series of fixed size block. You can see here the most important symmetric algorithm of all which are block cipher nowadays. For example, DES, triple DES, and advanced DS. For your information, before AES accepted to become worldwide using by the industry, DES actually the prior to that, right? DES, and then they introduced triple DES, and then they found that triple DES is not secure enough, so that's why they find another solution, ES. So this is the things. This average time equal to exhaustive key search, meaning if you want to brute force, okay, here you find AES triple dash how much, how many times. If you using AES 1 to 6, 1 to 8 key, they require this years 5.3 times 10 power of 70. How many years? You calculate 10 power of 70 years. But if the quantum computing there, maybe they will be reduced significantly. So later, you can see with the longer key size of AES, they will be required more. Yes, meaning is invisible, like visibility of crack using brute force attack would be higher. So meaning more secure. Time required higher, meaning more secure. So why it's important? Maybe later if you are asked by your top management, why we need this AES, why we need to encrypt? So you can justify. Because if not encrypt, maybe they will be exposed to the data breach and so on. So, okay, now we move directly to AES. We have ample time to complete by next week as well. So AES itself actually US standard FIPS 197 to replace DES. They have fixed block size. This is for ciphertext, the plaintext size and ciphertext size. The block, okay, the block size 1 to 8 bit, but the key size can be supported until 256. They use substitution computation network SPN base. So that's why I show you the figure last time, right? Okay, they have structure, operate on 4x4 bytes and apply series of transformation using 10 round, 12 round, and 14 round. Okay. We have each round function, we got this core operation, sub5, chip row, mix column, and account key. I don't want to give you a haircut because you are applying it not to produce another cryptographic algorithm. If computer science student with one course for this cryptography only, maybe I can give them all day the round. So each round is to prove it. To prove. So I sampled last time because there are no, I think there are not much internet resources last time. So we really need to calculate manually. Nowadays there are a lot. I learned 20 years back. Okay. This is an AS1 operation, PCB, ciphertext. So meaning 940 already. So give me another 5 digits before I give you your attendance. Okay, this is how the AES mode of operation using ECB, CBC, FP, OFP, CTR. This is the mode of operation. Then I will summarize for you how it works, the limitation of the block mode, and then what are the security level. So meaning here, if you found the previous Wi-Fi cryptography, right? They are using specific they have their own specific. For example, they using last time they using CCMP. So that's why here. So you need to know CCMP OCP1. So CBC already replaced by this one CFP driver block. And then there are also CTR nowadays, high modernization fully parallelizable for high speed system. Because why? Nowadays there are more demand. If they say you want to implement in mass communication, in mass AI deployment, for example. So you need more modern and parallelizable operation, of interoperable and so on. So you need to ensure which one can satisfy your requirement. Although they are using AES, but the mode of operation can be different. Maybe this one we can try to understand what the different limitation and also the security level. Most of the time, you will see the security level and how it's working. Okay, for the hash function, I think we can continue next week. But we have 4 hours, right, for this. The Okay, tomorrow, your lab session, just bring your own laptop. BYON. Bring your own laptop. Anyone don't have laptop? You can use that see, I request the technician to install the
I think
we'll go through together. So the first executive support. With the